Hi everyone, my name is Iliya, and I'm the co-founder of 365 Data Science. I hope you're excited because we'll be talking about some really important data science stuff in this video. And if you're here, chances are you already know a thing or two about the topic, which makes this even more exciting for me. But first things first, for those of you who don't know 365 Data Science yet, we are an online training platform for aspiring data scientists. You might have seen our name tossed around websites like KD Nuggets, Big Data Made Simple, or towardsdatascience.com. But even if you haven't, that's okay. What we're going to talk about here is not tailored to professional data scientists anyways. It's for anyone who's interested in what data science is, why it's the #1 job in the US right now, actually 4 years in a row, and how you can make a career as a data scientist who's paid that oh-so-lovely 6-figure salary. So, if you're a professional, you really won't benefit from watching this video. But if you're a beginner or a motivated quick learner who wants to learn more about how to make it in this field, stick around. Also, we'll talk a little about the best online training for aspiring data scientists at the end. And we'll share a special YouTube coupon for those of you who want to sign up at a substantial discount. So yeah, stick around. There's plenty awesome stuff coming. All right, moving on. Now, we didn't become data scientists overnight, and we're not offering you a magical solution that will get you hired tomorrow. We read the textbooks, did tons of practice, read some more books, the familiar cycle. But all of us really started thinking like data scientists once we understood what data science is. Sounds like the easiest thing, right? Yeah, but you'd be surprised how tricky it is to put all the buzzwords and tech terms together and have them make sense. Anyway, what we extracted from our experience are 3 knowledge pillars. 3 data science pillars around which all your learning and career drive need to be organized. And that's what we'll talk about right now. These 3 pieces of information that help you make sense of the field and the many opportunities it offers. The terms in data science, how they fit together, and the timeline of data science processes. All right, let's get started. As I said, my name is Iliya, and I am the co-founder of 365 Data Science. I am also responsible for all things mathematics, statistics, machine, and deep learning related here at 365 Data Science. I am co-hosting this with my colleague, Simona. She teaches R programming and stats, and I'm going to pass the mic to her for a minute.
Hey everyone! It's pretty awesome to be here and talk to you about data science, because there are definitely some confusing things in the data science world and misconceptions flying around.
See, we feel like data science terms and related buzzwords are being tossed around by people from all walks of life who have taken an interest to the topic. This is not to say that they don't know what they are talking about. On the contrary, but they often use the terms of data science assuming everyone knows and understands where these terms come from and how they fit into the bigger picture. What I mean is, often the people discussing data science are not teachers. And this creates a massive amount of uncertainty or confusion for the beginner data scientists. There's also a lot of step-by-step guides out there about how to become a data scientist. But nobody really delves into what data science is, how and why it works the way it does.
Okay everyone, so data science. Can you give a single comprehensive definition of what data science is? Try it. I believe it will prove extremely difficult to come up with something that doesn't invite 100 follow-up questions. That's the thing about data science. It's a universally recognizable term that is in desperate need of dissemination. From my experience, I believe this is a term that escapes any single complete definition, which makes it difficult to use, especially if the goal is to use it correctly. Most articles and publications use the term freely, with the assumption that it is universally understood. However, data science, its methods, goals, and applications evolve with time and technology. 25 years ago, data science referred to gathering and cleaning data sets, then applying statistical methods to that data. In 2018, data science has grown to a field that encompasses data analysis, predictive analytics, data mining, business intelligence, machine learning, and so much more. Right. In fact, because no one definition fits the bill seamlessly, it's up to those who do data science to define it. Here's the plan. We will define the key processes in data science and get to a complete description of the field. Why? Because if you want to be a competitive job applicant, you need to understand how various data science activities fit into the big picture. You'll also need to learn about the timing of the different data processing analyses, as well as who carries them out, and let's not forget how. Does that make sense? If you want to work in medicine, you will learn how the human body functions and then decide whether you want to be a pediatrician, a nurse, an oncologist, etc. That's what we're about to do here, but for data science. Let's start with a picture. This is data science in a nutshell, but we're not interested in just the nutshell. This infographic contains the most concise representation of data science terms that we know of, and ultimately, all the things you need to have a solid grasp of before entering the field of data science. I mean, that was our grand idea when we designed it, right?
You are absolutely right, Simona. By the way, if you guys want to download the infographic and this entire presentation, there's a link in the description that will take you to our download page. Or you can click the widget on the screen to the same effect. Okay, let's get started by talking about data. Before anything else, there is always data. Data is the foundation of data science. In the context of data science, there are two types of data, traditional and big data. You've heard of both, I don't doubt that. Traditional data is data that is structured and stored in databases, which can be managed from one computer. It is in a table format, containing numeric or text values. Big data, on the other hand, is bigger than traditional data, and not in the trivial sense. It isn't simply represented by numbers and text, but also by images, audio, mobile data, and so on. In addition, big data has high velocity. What does that mean? It means that it's retrieved and computed in real time. Finally, think about its volume. Big data is measured in tera, peta, and exabytes, and it is often distributed across a network of computers. Why? Because it is very, very big. So, to get some perspective, where does it all come from?
Well, traditional data may come from sources like basic customer records of a retail store or historical stock price information in the world of finance. Big data, however, is all around us. A consistently growing number of companies and industries use and generate big data. Consider online communities, for example. This might seem like an anecdotal example, but really think about it. Facebook, Google, and LinkedIn. They generate massive amounts of user data. Facebook alone, for example, collects information about the pictures, places, posts, demographics, products used, audio, and video shared of all its 2.2 billion users. In fact, right now, digital data in the world amounts to 3.2 zettabytes. That's 3.2 times 10 to the power of 21. And collectively, 90% of all the data we have, since the beginning of time, has been collected in the last 2 years. That's a scary amount of big data gathering, and it's only going to grow.
Right. Now, imagine the following scenario. You're already a data science professional, and you are working for a telecommunications company. A superior member of staff tells you one of two things. A. We need to consider client satisfaction in the next quarter, so we can predict churn rate. Oversee the process and come up with some numbers. Or B. We have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? Can you pinpoint the difference between A and B? I'll give you 10 seconds. The difference is that, in the first case, you do not have data. You would need to gather it. This data can come from surveys, like asking people how much they like or dislike a product on a scale of 1 to 10. Okay. So, you have surveyed all these people, and their responses have been sent to you. Is this data ready to be analyzed? Not exactly. This is called raw data because you still haven't done any processing on it. It is untouched data that cannot be analyzed straight away. Awesome! Now, let me introduce a new term, pre-processing. This is what we can think of as preliminary data science. Pre-processing is an absolutely crucial group of operations that convert raw data into a format that is more understandable and hence useful for further processing. Plus, it fixes the mistakes that occurred during the gathering phase. If you've ever worked with data before, then you know these happen constantly. Like when we're thinking about customer data, it's unrealistically easy to have a person register as 932 years old, called United Kingdom, from Kevin Smith as their country. Obviously, those data entries are incorrect, and therefore must be handled before proceeding to any type of analysis, right?
Yeah, absolutely. That's why there are tons of pre-processing practices in place. I'll tell you about some of the more common ones. First is class labeling your observations. This consists of arranging data by category or labeling data points to the correct data type. For example, numerical or categorical. Number of goods sold daily would be numerical. You can manipulate this information mathematically, and a person's profession or place of birth is categorical because no mathematical operations can be done on this information. All right. Just keep in mind that with big data, the classes are extremely varied. Therefore, instead of numerical versus categorical, the labels will be text, digital image data, digital video data, digital audio data, and so on. Okay, then there is data cleansing or scrubbing. These are techniques for dealing with inconsistent data, like misspelled categories and missing values. You know the lot, people sharing their name and occupation, but omitting their age or gender. Data shuffling is another interesting one. Imagine shuffling a deck of cards. It ensures that your dataset is free from unwanted patterns caused by problematic data collection. Like what? Like if the first 100 observations in your data are from the first 100 people who have visited your website. This data isn't randomized, and it's likely to reflect just the behavior of those 100 people when your website was still under construction. In a word, data shuffling prevents patterns due to sampling to emerge. And finally, consider data masking. This is primarily a big data-specific technique, and no wonder. When collecting data on a mass scale, you can accidentally put your hands onto a lot of sensitive information, which you need to urgently hide from yourself. Masking aims to ensure that any confidential information in the data remains private, without hindering the analysis and extraction of insight. Essentially, the process involves concealing the original data with random and false data, allowing the scientists to conduct their analyses without compromising private details.
And let's not forget, all of this is just at the very beginning of doing data science. Pre-processing your data to make it usable is laying the groundwork. All right, let's assume your databases are clean and organized at this point. So, let's get into the real deal now. Before we begin, I want to make sure we are on the same page here. There are two ways of looking at data, right? One, with the intent to explain behavior that has already happened, and you have gathered data for it. And two, to use the data you already have in order to predict future behavior that has not yet happened. You need to be very clear on this distinction because it can be what tilts the scales one way or another when you're deliberating which data science path is best for you. There is also a temporal relationship between the two ways of looking at data. Basically, before data science jumps into predictive analytics, it must look at the patterns of behavior the past provides, right? It must analyze them to draw insight, which will then inform the direction in which forecasting should go.
Yep, and there's a name for the data science that focuses on explaining the past. That's business intelligence.
Think about it this way. Business intelligence provides data-driven answers to questions like, how many units were sold? In which region were the most goods sold? Which type of goods sold where? How did the email marketing perform last quarter in terms of click-through rates and revenue generated? How does that compare to the performance in the same quarter of last year? Although business intelligence does not have data science in the title, it is part of data science, and not in any trivial sense. I'm sure you're beginning to get that feeling already, right? So, what do you do as a business intelligence analyst? Of course, data science can be applied to measure business performance. But in order for the business intelligence analyst to achieve that, they must use specific data handling techniques. Let's review some of them. Right. So, the starting point of all data science is data. For BI analysts, that consists of things like monthly revenue, customer volume, sales volume, and so on. And as soon as they get their hands on that data, they must go through three fundamental operations. First, extract meaningful metrics from the dataset, like average quarterly revenue per new customer. Second, identify the key performance indicators. Only those metrics that will clearly show how the business is doing. And third, analyze the data to extract insights from it. Think about it for a second. Why is business intelligence an important data science stepping stone? Well, consider this. The company you're working for is running a marketing campaign, and you have received the data. You examine it and identify one of the metrics. It indicates all the traffic to a page on your website. Then, you think about what a KPI could be in this case, and you realize that a KPI would show the volume of the traffic to the same page, but only if generated from users who have clicked on a link in your ad campaign to get there. This way, you can check if the ads you're positioning are in fact working and driving customers to click on a link. In turn, this will determine whether you should continue to spend on ads or not.
Of course, this is not where the business intelligence analyst responsibilities conclude. I want to keep in mind this next thing I will tell you. Really, hold on to it. Data science is about telling a story. I will say that again. Data science is about telling a story, and crunching the numbers is just the introduction to the story. So, apart from handling strictly numerical information, data science, and specifically business intelligence, is about visualizing the findings and creating easily digestible images supported only by the most relevant numbers. After all levels of management should be able to understand the insights from the data and inform their decision-making. And this is in the hands of the business intelligence analyst. Business intelligence analysts create dashboards and reports accompanied by graphs, diagrams, maps, and other comparable visualizations to present the findings most relevant to the current business objectives.
That's all super interesting, but what are the directly actionable results of these analyses? What line of work would need a BI analyst? In other words, where would you come in as a BI analyst? Let's try using our analytical brains and try to answer that together.
If you are a hotel manager, would you keep the prices of rooms constant all year round? Probably not, if you want to attract visitors when the tourist season is not in bloom, and if you want to capitalize on it when it is. And how would you inform your strategic decisions to lower or increase room prices?
With BI Insight, data science is constantly applied to inform price optimization techniques. What BI analysts can do is extract information in real time. Think about booking sites. And then compare this to historicals, update the dashboards, and reflect the necessary price change instantaneously. The exciting bottom line is, BI allows you to adjust your strategy to past data as soon as it is available.
All right, here's some more food for thought. Think about inventory, of any sort, really. Which is better, oversupply or undersupply? If you choose secret option number 3, neither, you are correct. Over and undersupply can cause massive problems in a business. Too much inventory and you lose money you have already invested. Too little inventory and you lose money you could have potentially gained. And implementing effective inventory management means supplying enough stock to meet demand with the minimal amount of waste and cost. And the million-dollar question, how do you ensure your inventory management is effective? Data science and business intelligence are invaluable for handling over and under supply. A BI analyst can carry out in-depth analyses of past sales transactions to identify seasonality patterns and the times of the year with the highest sales. This can then inform inventory managers and result in the implementation of effective inventory management techniques that meet demands at minimum cost.
Easy. Once the BI reports and dashboards have been prepared and insights extracted from them, this information can become the basis for predicting future values. And that's where it becomes truly awesome. But the accuracy of your forecasts will differ based on the methods and techniques you decide to apply. And this is where the more popular data science concepts come out to play. Examples of such techniques are neural networks, deep learning, time series, and random forests. But let's backtrack a little. Just as there is a distinction between traditional and big data, there is also a distinction between traditional methods in predictive analytics and machine learning. Judging by the way I've positioned these, can you guess what the basis of this distinction is? That's right. It's the type of data that methods operate on. Traditional invites traditional analytics, like regression, cluster, and factor analysis, whereas machine learning is far better equipped to handle big data. As you can imagine, machine learning steps on the shoulders of classical statistical forecasting. In fact, people in the data science industry refer to some of these methods as machine learning too. But when I talk about machine learning, I am referring to newer, smarter, better methods like deep learning. Just something to keep that in mind. Right. Now, what's the statistical knowledge you need for traditional analytics in data science? Most often, data science employs one of these 5 analyses: linear regression, logistic regression, cluster analysis, factor analysis, time series analysis. Okay, let's do a little exercise. I will describe what each analysis does, but I won't tell you its name. Your task is to try and match the methodology with the correct name. Think of this as a self-test. How well do you know your way around the fundamentals of statistics? It'll give you a relative idea of whether you're prepared for practical interview questions for a data science position. All right. This method is used for quantifying causal relationships among the different variables included in the analysis. You will use this if you need to assess the relationship between house prices, the size of the house, and the year they're built. The model calculates coefficients with which you can predict the price of a new house if you have the rest of the relevant information available. Is this cluster or factor analysis? Or is it time series analysis? If you said it's a regression, you are correct. But which type? This, of course, is linear regression. There is a line which governs the relationship between the size and the price. Okay. This exploratory data science technique is applied when the observations in the data form groups according to some criteria. It takes into account that some observations show similarities and facilitates the discovery of new significant predictors, ones that were not part of the original conceptualization of the data. If your house data looks like this analysis would identify these groups: small expensive houses in the city center, big cheap houses in the suburbs, and big expensive houses in good neighborhoods. This, of course, is cluster analysis. Next one. If clustering is about grouping observations together, this analysis is about grouping features together. Data science resorts to using it to reduce the dimensionality of a problem. Let me explain. If you have a questionnaire with 100 questions, and each 10 questions are trying to determine a single general attitude, this analysis will identify the 10 factors. Did you guess this correctly? This is factor analysis. Once factor analysis identifies some factors, they can be used for a regression that will deliver a more interpretable prediction. I hope you're not surprised. A lot of the techniques in data science are integrated like this, which is why a solid fundamental understanding of statistics is genuinely a must. We're left with two statistical methods, time series analysis and logistic regression. That's almost too easy, but let's do it anyways. This is a popular method for following the development of specific values over time. It is widely used in economics and finance because their subject matter is stock prices and sales volume, variables that are typically plotted against time. I'm sure you noticed that I said the word time about 16 times. This description is, of course, time series analysis. And finally, logistic regression. Since not all relationships between variables can be expressed as linear, data science makes use of methods like logistic regression to create nonlinear models. Logistic regression operates with zeros and ones. For instance, think about the process of hiring new staff. Companies apply logistic regression algorithms to filter job candidates during their screening process. If the algorithm estimates that the probability that a prospective candidate will perform well in the company within a year is above 50%, it would return 1, or a successful application. Otherwise, it will return 0, and that candidate will not be called in for an interview. Does that make sense? I'm pretty sure things are starting to click already.
Just keep this in mind. Linear and logistic regression, cluster and factor analysis, and time series are at the core of the traditional methods for predictive analytics in data science. A lot of the smart advanced machine learning methods for data handling are heavily grounded in this statistical theory. So if you're interested in data science, please make sure to cover these foundations well. It'll be a complete game changer. This is also one of the reasons why our program starts from scratch, explaining math and statistical fundamentals first, before studying more advanced topics. Okay, now that you know what traditional data science does, you are definitely trying to think of the practical applications and where it fits in the world. Or at least you are now. The application of these analyses is extremely broad. Data science is finding a way into an increasingly large number of industries, and it's getting incredibly creative. But user experience and forecasting sales are still the big names here. Think about it. When companies launch a new product, they often design surveys that measure the attitudes of customers towards that product. That's a crucial marketing step. After the BI team has generated their dashboards, the data scientists can spread their wings. They can analyze the results by grouping the observations by segments, for example, sales regions, and then analyzing each segment separately to extract meaningful predictive coefficients. After all calculations are complete, the team reaches the conclusion that the product needs slight but significantly different adjustments in each segment to maximize customer satisfaction. Only then can everyone be happy. And isn't that the goal? What about forecasting sales volume? This type of analysis invites time series onto the scene. You have sales data that's been gathered until a certain date, and you want to know what is likely to happen in the next sales period or a year ahead. You apply mathematical and statistical models and run multiple simulations. These simulations are what provides you with future scenarios. This is at the core of data science, because based on these scenarios, the company can make better predictions and implement adequate strategies. Don't worry if this sounds a little vague at this point. Data science is massive, and sometimes you need the bird's eye view to stay on track.
All right, we are now at the end of the line. We've looked at data, explanatory dashboards from the BI team, and predictive analytics using classical statistical approaches. Data science is coming into shape, but it's missing one powerful methodology, isn't it? In fact, that's what most people consider true data science: machine learning. But just as it doesn't make sense to learn how to run before you can walk, approaching machine learning needs to be done with caution. Do you understand the basics? If you've been paying attention, you have a good idea at this point. So, machine learning is the state-of-the-art approach to doing data science, and rightly so. The main advantage machine learning has over any of the traditional data science techniques is the fact that at its core resides the algorithm. You have heard of it before, I am sure. These are the directions a computer uses to find a model that fits the data as well as possible. The difference between machine learning and traditional data science methods is that in machine learning, we do not give the computer instructions on how to find the model. It takes the algorithm, performs a trial and error-like process to find it out on its own. Unlike in traditional data science, human involvement is minimized. In fact, machine learning, especially deep learning algorithms, are so complicated that humans cannot genuinely understand what is happening inside, even though we are the ones that design them. Isn't that fascinating?
But let's get back to the algorithm, because that's the core. A machine learning algorithm is like a trial and error process, but the special thing about it is that each consecutive trial is at least as good as the previous one. That opens the door to much more accurate predictions and models. But bear in mind that in order to learn well, the machine has to go through hundreds of thousands of trial and errors, with the errors decreasing throughout. Then, once the training is complete, the machine will be able to apply the complex computational model it has learned to novel data and still produce highly reliable predictions. This is where the power of machine learning lies, and the reason why it's considered the epitome of data science.
Okay, to give you a better idea of how machine learning works, there are three major types of machine learning: supervised, unsupervised, and reinforcement learning, right? If you've been following data science trends, you should have at least heard about them. Imagine having some data, a lot of it actually, big data, consisting of video files and images. And you have labeled your data. These are videos of cats, these of dogs, and third are animals that are neither cats nor dogs. In supervised learning, you want to have labeled data just like the one you have right now. The machine gets the data, and that data is associated with a correct answer. If the machine's performance does not get that correct answer, an optimization algorithm adjusts the computational process, and the computer does another trial. Of course, keep in mind that, typically, the machine does this on a batch of, say, 1,000 data points at once. Machine learning is powerful. That's the takeaway here, and I will probably say it at least once more. Support vector machines, deep neural networks, random forest models, and Bayesian networks are all instances of supervised learning. All right, let's get back to the data again. But this time, imagine it's not just big. It's too big, and you cannot label it. Or you are too pressured for resources to take the time to do that, or you don't know what the labels are at all. In this case, data science resorts to using unsupervised learning. This consists of giving the machine unlabeled data and asking it to extract insights from it. This often results in the data being divided in a certain way according to its properties. To use the term we just discussed, it is clustered. See how traditional methods spill into machine learning?
The really cool thing about unsupervised learning is that it is extremely effective for discovering patterns in data, especially things that humans using traditional analysis techniques would miss. In our case, this could be a whole new animal group we've missed, like pictures and videos of alligators, which we would have otherwise labeled neither cats nor dogs.
Actually, data science often makes use of supervised and unsupervised learning together, with unsupervised learning labeling the data and supervised learning finding the best model to fit that data. But we can discuss this another time. There's a more pertinent question here. Where is machine learning applied in the world of data science and business? Think about fraud detection. With machine learning, specifically supervised learning, banks can take past data, label the transactions as either legitimate or fraudulent, and train their models to detect fraudulent activity. When these models detect even the slightest probability of theft, they flag the transactions and prevent the fraud in real time. Pretty impressive, isn't it? And in terms of corporate, ML is indispensable for client retention insights.
With machine learning algorithms, corporate organizations can know which customers are likely to purchase goods from them. It's again follow the pattern kind of activity. And this means the store can offer discounts and a personal touch in a very efficient way, minimizing marketing costs and maximizing profits. When talking about this technique, one name always comes to mind: the e-commerce giant Amazon.
All right, let's quickly do a recap. Data science is a slippery term that encompasses everything from handling data, traditional or big, to explain patterns and predict behavior. Data science is done through traditional methods like regression and cluster analysis, or through unorthodox machine learning techniques. It is a vast field, but right now you are one step closer to understanding how all-encompassing and intertwined with human life it is. And we will give you one better. Did you notice we haven't said anything about programming languages and the software data science uses? That's because we wanted to run you through the ABCs of data science first, and then discuss the most useful tools for each data science subfield.
Okay, so we can split data science tools into two categories: programming languages and software. Knowing a programming language enables the data scientist to devise programs that can execute specific operations. So, the biggest advantage programming languages have over software is that they offer massive flexibility. As you can imagine, capable programmers can write code that lets them do to data pretty much anything that strikes their fancy. R, Python, and MATLAB, combined with SQL, cover most of the tools used when working with traditional data, BI, and conventional data science. In fact, R and Python are the two most popular languages across all data science subdisciplines. We actually carried out our own extensive research looking into 1001 data scientists and their backgrounds, and 53% of them knew R and/or Python. Yes, the overlap is huge.
Why are they so popular? Well, their biggest advantage is that they can manipulate data and are integrated within multiple data and data science software platforms. They are not just suitable for mathematical and statistical computations, they are adaptable. SQL is king, however, when it comes to working with relational database management systems, because it was specifically created for that purpose. SQL shines brightest when working with traditional, historical data, for example, when preparing a BI analysis. What about big data? Big data and data science is handled with the help of R and Python, of course, but people working in this area are often proficient in other languages like Java or Scala. These two definitely come in handy when combining data from multiple sources, which is not a rare occurrence. Trust me. Right, let's talk about software for a minute. A lot of software is used in data science, especially in corporate, because it is just that, a tool adjusted for the specific business needs of a company.
Yeah, for example, Excel is definitely a household name and a tool applicable to more than one category: traditional data, BI, and data science. Similarly, SPSS is a very famous tool for working with traditional data and applying statistical analysis.
TensorFlow, on the other hand, is software library designed for working with big data and designing machine learning algorithms. It was developed by Google for internal use, became public in 2015, and is generally the leader for working with and deploying neural networks. You've also heard of Apache Hadoop, Apache HBase, and MongoDB. I don't doubt that. These are two big data-centered software. On the visualization side of the court, especially having business intelligence reports and dashboards in mind, Tableau is unparalleled in terms of ease of use, versatility, and looks. All right, that about covers it. This is data science in 30 minutes.
So let's do a quick recap, everybody. We talked about data, where you get it from, and what type of pre-processing operations you must be comfortable with before the real data science begins. If there is one takeaway here, it is that data is the foundation of anything data science does. If you cannot understand how to work with raw data, you will not be able to get into the more sophisticated analyses.
So, action point number 1. If you're thinking of starting on the data scientist path, learn how to handle data.
We also looked at business intelligence and saw the clear-cut line between predictive data analytics and explanatory analysis. Business intelligence focuses on explaining past business behavior. These analyses are the stepping stone for predicting how businesses will perform in the future. Learn the past to know the future. Makes sense, right?
And this leads to action point number 2. Be comfortable with extracting insight from past data first, and only then proceed to making forecasts about your company's business performance in the future.
We mentioned dashboards and presentations too. Data science is about telling a story, and that story includes both numbers and visuals, okay? To be an effective storyteller, you must visualize the insights you draw from your data. Otherwise, if your audience is not number savvy, the point you're trying to get across won't make any impact, and your work will go unnoticed. In most cases, that's not ideal. For me, at least.
So, action point number 3. Learn data visualization. Tableau, ggplot2, matplotlib, Seaborn. Any software would do the trick.
Then we talked about the traditional methods of predictive analytics, right? Regressions, factor and cluster analysis, time series, the bread and butter of forecasting. A lot of the more advanced approaches to data science, like machine and deep learning, rest on the theory at the core of these methodologies. Hate to sound like a conspiracy theorist, really, but the beautiful, marvelous thing about data science is that everything is connected. And honestly, I believe this is one of the main reasons why it's difficult to find your way around as a beginner. Does that make sense? Okay, cool.
Action point number 4. As far as statistics is concerned, cover the foundations first before playing with the big guns, like neural networks, ML algorithms, and so on.
And only once the foundations are covered can we talk about, and we did, the state-of-the-art approach to data science, machine learning. These are the newest, smartest, best methods for predictive analytics, including deep learning, neural networks, k-means clustering, and reinforcement learning. Mastering machine learning is definitely the number one skill you need to start a career in data science, but it is also the most challenging data science subfield.
Action point number 5. Build a portfolio of ML projects, even if it takes you some time. Practice will be your best teacher, and you will have something to show for during your interviews.
Absolutely. Okay, we also looked at programming languages. There is a ton of research that indicates that data scientists, on average, can comfortably work with 2 languages. In most cases, that's some combination between R, Python, and SQL.
I guess the action point here is simple. When it comes to programming languages, learn 1 or 2, but learn them well.
Finally, have fun. Data science is awesome and exciting and opens up a world of possibilities, really. So don't stress out too much and enjoy your journey. Okay, I'm super glad we cleared all of that up. And if you're really serious about developing some data science skills, we can definitely give you some guidance.
For sure. I, for one, hope you feel like the time you just spent learning about data science was worth it. Not only because you now have a clear data science path you can follow if you choose to develop your data scientist skills, but also because we are a motivated team and we are going to show off something we're super proud of. And you get to be a part of it. You'll see how. All right. It's called the 365 Data Science Online Program, and it says it all in the name. This is the comprehensive data science curriculum my co-founders and I set out to develop, so others wouldn't have to invest as much time, energy, and resources as we did when we were growing our own data science skill sets. It's a pretty awesome program. That's actually something our students say too, which is great because it totally validates everything we are trying to achieve, which is creating an accessible and transparent fast track into data science. About our R and statistics training, Matthew says that while other courses have been somewhat helpful, with us, he managed to really get into doing statistics with R and actually had fun doing it. And Rajiv was absolutely thrilled with our machine learning portion of the program. He says it's both in-depth and logical, unlike a lot of the resources you can find scattered online. That's exactly what we are aiming to do. So that's spectacular. He also says that building models from scratch helped him learn a lot and to certainly see the real-world business applications of ML. Annabelle, on the other hand, is already a data science grad student, and she finds our statistics training flawless and super intuitive. She says it's essential, especially if you're going into machine learning. In fact, she would recommend the course to anyone in the data science field, which is absolutely fantastic and makes us really, really happy to hear that.
Now, the program includes a lot more than these courses, and we've created it with the entire professional journey in mind. So, we've designed trainings for all of the skills that step-by-step build up the data scientist, including the fundamentals of mathematics, probability, statistics, Tableau, SQL, R, Python, all the way to machine learning.
Yes, and this way, when you start growing your skill set, you will be able to do it systematically in a structured, practice-rich environment. And if your motivation is at the level we think it is, you'll complete the training in a couple of months instead of years. In fact, I'm pretty sure that most of you guys are already highly motivated, and you're here because you've been trying to teach yourself on your own and find the right way through the labyrinth of resources available online, right? So, how do you get to be a part of this? Well, we've created a secret coupon for only those of you who are with us in this presentation, because that's our way of saying thanks and reaching out.
There's a link to the side of the screen that says Subscribe Now. If you click that link, it'll take you to a subscription page where you will be able to enroll in the 365 Data Science Online program with 75% taken off the standard non-webinar price.
This offer is only available to the first 100 people who sign up, so make sure to claim yours before the coupons are all gone.
We know that's a massive discount, but we decided to do it so we can make this gateway into data science an accessible reality. We kind of feel like you're being here. Talking to us online is a pretty good sign that you are serious about your future in data science. So this way, all of you that enroll will have access to a massive amount of resources, and you will be able to learn a lot, as well as see if it makes sense for you to continue on the data science path.
What we really hope will happen, though, is that you will realize how awesome and full of opportunities data science is. And you will let us help you become a more effective professional. So, to recap,
As our amazing webinar audience, you get a free coupon to begin the 365 Data Science online program at 75% off. The discount will only be applied to the first 100 of you who enroll in the training, which means that once the coupons are gone, they're gone. Clicking on the Subscribe Now widget next to the screen will claim the coupon, so claim yours soon.
And after that, we'll see you in class.
All right, everyone. Thanks for watching. We are super glad data science terminology is no longer confusing in your minds. And just a reminder, if you want to get all the materials we used in the video, the infographic, and the presentation, there's a link in the description that will take you to our website, where you can download them from. Or you can click on the widget on the screen now. Thanks and good luck.
Yeah, we had a lot of fun. Good luck, everybody.